The Tuscarora Lapidary Society teaches a wide variety of lapidary techniques at its education center in Brookhaven, Pennsylvania. One of the most basic is the making of gemstones with many flat surfaces called facets. The resulting gem is called a faceted gem. This short video shows the equipment that we use in making faceted gems and the procedure from the selection of a piece of rough to the completion of the faceted gem. The procedure of making a faceted gem is called faceting. Most faceted gems are transparent, like the one shown in this simulation, in which case the facets give the gem a sparkling look as light travels into and then back out of the gem after reflecting internally off of the facets. One can also get interesting effects by faceting opaque materials, in which case light simply reflects off of the facets without traveling through the gem. Here are a few examples of faceted gems: iolite on the left, amethyst in the middle, and topaz on the right. Diamond faceting requires very special equipment. We teach faceting of gem materials other than diamonds, including various natural materials such as amethyst, citrine, and sapphire, as well as glass and various synthetic materials. Everything in this video pertains to faceting materials other than diamond. This photo shows a collection of pieces of colored glass suitable for faceting. It is a perfect material for the beginning student since it cuts rather easily, since it can make a very pretty gem, and since it is very inexpensive. Faceting is done on faceting machines that are produced by a variety of manufacturers. We use the Mark 5XL with a digital angle display made by the Graves Company. These machines include a motor that drives discs, called laps, containing grinding or polishing material. One can control the speed that the laps rotate. A water tank supplies water that keeps grinding and polishing cool, and that washes away material that has been ground off of the rough gem. The tall steel post on the faceting machine, called the mast, allows vertical positioning of the faceting head that contains a shaft which rotates on two axes, allowing rough material attached to the shaft to be placed on the lap in any position. A digital readout displays the angle that the shaft makes with the mast. When the shaft is horizontal, the reading is 90 degrees. An index wheel allows one to control the rotation of the shaft on its axis. We are using an index wheel with 96 evenly divided positions. Here are some faceting laps. The one on the left is a copper lap to which we apply loose diamond grit of a specific size, along with a little grease or oil. The diamond embeds easily into the copper and makes a very good grinding surface. The lap in the middle is a plated lap that is manufactured with the diamond grit embedded in a metal matrix. The lap on the right is a ceramic polishing lap on which we apply a very fine grit of diamond for polishing a variety of gem materials. The material to be faceted is attached by a special wax or by epoxy to a short metal shaft called a dop. The dop fits into the faceting arm shaft on the faceting machine. Here we see epoxy being used to attach a dop to a piece of green glass that will be faceted. The piece of equipment that was just used in attaching a dop to the glass to be faceted is called a transfer jig. We will use the transfer jig again later when transferring cutting from the bottom to the top of the gem. There are many patterns from which to choose when faceting a gem. A separate long video could be used to illustrate the choices involved and how they relate to the optical properties of the gem material being faceted. We are simply going to be following this plan for the Perfect Brilliant designed by Jim Perkins. The bottom part of the gem is called the Pavilion. The top part is called the crown. The narrow area that separates the top and bottom is called the girdle, and the point, or sometimes a tiny facet, at the bottom is called the culet. Once the epoxy has set completely, some initial rounding is done. If there is a significant amount of material to be removed, the stone can be preformed on other lapidary equipment, such as the Genie by Diamond Pacific, in order to approximate the final girdle shape. Preforming can also be accomplished on the faceting machine, or the stone can be cut directly without preforming. The dop is then inserted into the shaft of the faceting head. We begin to cut the pavilion facets labeled P1 on the faceting diagram. There are 16 of these facets, all cut at an angle of 43 degrees. At this stage, we are using a fairly coarse 180 grit diamond lap that leaves a frosted-looking surface that will need to be ground with a finer 1200 grit diamond lap and then polished. The higher the grit number, the smaller the pieces of diamond doing the cutting, and the smoother the resulting surface on the gem. The initial rough grit cutting is a process called roughing in. Doing the initial cutting of the P1 facets goes a little faster if we alternate with cutting in the corresponding 16 girdle facets labeled P2 in the diagram. When the initial pavilion facets and the girdle facets are complete, the P1 facets all run from a central point to the girdle, and the girdle facets meet precisely at the edges of the P1 facets. In this view, the P1 and P2 facets have been smoothed using a well-worn 1200 grit lap. Next, we begin cutting in the 8 P3 facets at an angle of 41.5 degrees using a 1200 grit lap. Very little material is removed for these facets. The motto for cutting in small facets is, cut a little, look a lot. The P3 facets reach from the girdle to the culet. Next, the pavilion is polished, starting with the girdle facets, which need only to be polished near the pavilion, since the rest of those facets will be ground away in the creation of the crown. After the girdle facets are polished, the P1 facets are polished, followed by the P3 facets. By first blackening the facets, one is better able to see the progress of the polishing. Here we see the polished pavilion along with the dop that will be attached to the pavilion so that the crown can be shaped. The transfer jig is used to attach a dop to the pavilion. Special faceting wax can be used, or epoxy. Here we will be using a quick set epoxy. In the next video, the epoxy has been mixed and added to the cone-shaped dop that will be attached to the pavilion. Then the parts are slid together with the jig maintaining a straight alignment, and we rotate the jig to obtain a uniform application of the epoxy that is then let to cure. Overnight is best, even for quick set epoxy. After the epoxy has hardened, we need to remove the dop on the left side. In the next video, we have wrapped the stone and pavilion dop in a wet paper towel to keep those parts cool, and are applying heat from an alcohol lamp to the crown dop to remove it. There are 16 crown facets C1 cut at an angle of 41.5 degrees and at the same index wheel settings as the P1 pavilion and P3 girdle facets. In this view, the C1 facets have been roughed in and the thickness of the girdle facets has been determined. We are now starting to cut in the first of the 8 C2 crown facets at 35 degrees. These facets reach to the girdle, as is shown in the next short clip. The 16 C1 facets and 8 C2 facets plus 8 C3 facets at 21.5 degrees have all been cut at 1200 grit and are ready to be polished. The next video shows the beginning of polishing the C1 facets. Prior to polishing, the facets are blackened to make it easier to see the effect of touching a facet to the polishing lap. Sometimes small adjustments in positioning are necessary to get the facet to lie perfectly flat on the polishing lap. Here the C1, C2, and C3 facets have all been polished. It is now time to prepare to cut the large table facet. A special table dop adapter is aligned to sit perfectly flat on the lap, so that our faceted gem will be held in a vertical position on the lap. Here, everything is ready for cutting the table, the beginning of which is shown in the next video clip. The table facet has now been cut at 1200 grit and is ready for polishing. Again, we blacken it so that we can see if any adjustments are needed to make the table sit perfectly flat on the polishing lap. The table facet is polished and the gem is complete. We first remove the dop from the table dop adapter. Then there are various ways to remove the gem that has been attached to the dop with epoxy. One of the simplest is to use boiling water to soften the epoxy, as is seen in the next two short clips. The cutting and polishing of the gem is done. In the last short clip, we move the gem around a bit so you can see the sparkle as light is reflected back out of this beautiful green glass gem. This concludes our introduction to making a faceted gem. The Tuscarora Lapidary Society teaches many lapidary and jewelry techniques at our education center in Brookhaven, Pennsylvania, including cabbing, faceting, and silversmithing, among many others. For a complete list and for current classes, please visit our website, www.lapidary.org.